Welcome to Westell's Passive Components for Inquiring Minds. In this episode, we'll discuss antennas. What are the key specifications that help describe the differences between various antennas? There are many types of antennas, each suited for different uses. In this episode, we'll focus on the kinds of antennas used in public safety and cellular systems. Antennas are transducers. Transducers are devices that convert one form of energy into another. Specifically, antennas convert electrical energy into radio frequency energy and vice versa. Electrical energy is measured in volts and amperes. Electrical and magnetic fields describe RF energy. The electrical and magnetic fields are 90 degrees apart. The orientation of the electrical field is used to describe an antenna's polarization. For public safety and cellular antennas, the polarization is vertical. In case of cellular, it can also be a 45-degree slant. To achieve maximum power transfer from the transmitting antenna to the receiving antenna, it is important that they have identical polarization. Often, the polarization of many antennas can be determined by their physical orientation. Here we can see public safety antennas on a tower. They are vertically polarized. This is why the receive antenna of a public safety installation should always have its elements vertically positioned. Shown here are cellular antennas that appear vertically polarized but may be vertical or 45-degree slant. The 45-degree slant is achieved internally within the antenna's radome, its protective enclosure. 45-degree slanted polarized signals are less sensitive to the orientation of the receive antennas. The receive antenna may be vertically positioned, or in this position, or even this position. Not all antennas are created equal. Some designs make the antenna ideal for portable handsets, while others are suitable for indoor ceiling-mounted antennas, and another design is suitable when the radiated energy needs to be directed in one direction. Let's take a look at these designs. The simplest antenna design is a dipole. You may recognize dipole antennas as the rabbit ears on a television or the FM antenna included with a stereo receiver. A dipole antenna consists of two halves, with one driven by the positive side of the coaxial cable and the other by the negative side. The wavelength or frequency of the desired signals determines the length of each half. The details of wavelength and frequency will not be discussed here, but to summarize, the higher the frequency, the shorter each side can be. Lower frequencies require a greater length than higher frequencies. A close cousin to the dipole antenna is the monopole antenna. It is essentially one half of a dipole antenna, with only one side driven by the electrical signal while the other is grounded. To describe how dipole and monopole antennas radiate energy, the concept of antenna patterns must be introduced. An antenna pattern is often a 2D representation of the direction of transmitted energy from the antenna. Two 2D antenna patterns are needed to visualize the radiated pattern in 3D. One of the two patterns is called the elevation pattern, or vertical pattern. This pattern is produced by imagining looking directly at the side of the antenna and seeing the radiated signal. This is what both a dipole and a monopole antenna look like. From this view, we can see it radiates left and right, but not so well up and down. The second pattern is generated by looking down at the antenna from above. This is called the horizontal or azimuth pattern. From this vantage point, we can verify that it radiates not only left and right, but also forward and behind. In fact, it radiates in all directions in that plane. If both of these 2D patterns are combined, a 3D pattern can be visualized. Using the 3D pattern, we can easily see that the radiating pattern resembles a bagel or donut shape. This radiation pattern is what omnidirectional antennas produce. An omnidirectional antenna transmits and receives signals all around it in the horizontal plane, but not so well directly above or below it. The ceiling antennas that are round or dimple-shaped are omnidirectional dipole antennas. It is important that these antennas are mounted on the ceiling so they radiate throughout the area. If mounted sideways on a wall, they would cover only the ceiling and floor. Not exactly what is intended. The antennas on portables are monopole antennas. Monopole antennas are ideal for this application because they require half the length of a dipole. Dipole and monopole antennas are omnidirectional. They radiate equally in all directions in the horizontal plane. In some applications, this is desirable. In others, it is not. A directional antenna will focus its transmitted energy in one direction, limiting its transmitted energy in all the other directions. A directional antenna can be constructed by stacking dipole antennas. Internally, it looks like this. Electrically, it results in an antenna pattern like this. Directional antennas are used in applications where it is desirable to point an antenna in a specific direction. From the antenna patterns, the horizontal and vertical beam widths can be determined. While a directional antenna points most of its radiation in one direction, it is not like a laser beam. A significant amount of energy will be transmitted left and right from its direction and also above and below. The horizontal beam width describes how much energy is present to the left and right of the beam's main direction. Where the transmitted signal is reduced to half power on both sides is called its -3 dB points. The number of degrees between the two -3 dB points is its horizontal beam width. Looking from the side on the vertical antenna pattern, how much signal is directed towards the sky and ground can be determined by those -3 dB points. Antennas are said to have gain, which might lead someone to think its output power is more than its input power. This is not possible, as antennas are passive devices. The best that can be hoped for is that the output power equals the input power. In reality, some antennas get very close to this ideal. So if antenna gain does not increase the output power, what exactly is antenna gain? Antenna gain is used to describe the directionality of a directional antenna. The higher the gain, the more the transmitted signal is focused in one direction. Gain is measured in two ways, dBi and dBd. Gain measured in dBi reflects how much more energy will be directed as compared to an isotropic antenna. An isotropic antenna does not exist, but if it did, it would radiate energy equally in all directions. If gain is measured in dBd, the antenna's directionality is compared to a simple dipole. As the gain of an antenna increases, it focuses more power straight ahead towards its intended target and less towards the sky and ground. It does not affect the horizontal beam width. Speaking of pointing energy towards the ground, often when an antenna is on top of a tall tower, most of its transmitted energy will be directed towards the horizon, where in many cases there are no receivers to receive the signal. So down tilt is applied to direct the main beam towards the ground. It can be accomplished through mechanically tilting the antenna or electronically by manipulating the signal each of the stacked dipoles receive. Indoor antennas are usually very low gain, so they direct a lot of energy towards the floor without the need for down tilt. There are a few other specifications to consider about antennas. Its operating frequency. All antennas only work within a range of frequencies. An antenna for each application must be chosen that matches what the transmitted and received frequencies are. Wind loading. If an antenna is to be outside, what is its maximum wind speed it can tolerate before damage? Connector. Each antenna will have a connector. We must know which type so we can prepare a cable to attach to it. There are other antenna specifications that are beyond the scope of this video. Needless to say, when an RF engineer is choosing which antenna to use, they have a lot of specifications to consider. Thank you so much for watching.